made up of multiple components: the phosphate group, the pentose sugar, and as well as the various nitrogenous bases running down the middle. First off, sugar is attached to phosphate through phosphodiester bonds, and the nitrogenous bases are attached through hydrogen bonds. There are multiple types of nitrogenous bases: adenine, thymine, cytosine, and guanine. Here in base pairing, these bases are required to pair together for DNA to form. However, in RNA, uracil replaces thymine to bond with adenine. And also, there are two types of bases: purines and pyrimidines. Purines are double ring bases, and pyrimidines are single ring bases. The purines in DNA are adenine and guanine, and the pyrimidines are cytosine, thymine, and uracil and RNA.
In DNA, there are anti-parallel strands that connect to each other, starting with the 5' and ending with the 3', which is the pentose sugar, and on the other side, it's opposite, starting with the 3' to the 5', which is the phosphate sugar. This indicates in carbon numbers in the DNA's sugar backbone. The 5 carbon has a phosphate group attached to it, and the 3 carbon has a hydroxyl group. This asymmetry gives DNA a direction. For example, DNA polymerase works in a 5 to 3 direction, while the other goes from a 3 to 5. That is, it adds nucleotides to the 3 ends of the molecule, the OH group, thus advancing to that direction.
So DNA replication is started when helicase opens up the DNA strands by breaking the hydrogen bonds between the nucleotides. Shortly after, single-stranded binding proteins hold the individual DNA strands apart so they don't come back together. And then after these work together to unwind the DNA strands, a replication fork is formed. And when DNA nucleotides are added from the 5 to 3 direction going this way, they're moving away from the fork. But if they're moving this way, they're going towards the replication fork.
Now, the leading strand is the strand of DNA being replicated continuously. The leading strand starts from the 5' tip of the nucleotide to the 3' tip of the nucleotide direction by continuous polymerization at the 3' growing tip. Now, as primus is moving up this region, an RNA primer is being added to the base group, to the nucleotides. Now when these have been added, the DNA polymerase 3 comes up and adds nucleotides into the other strand of nucleotides. Now when the DNA polymerase 3 has done this, it adds nucleotides only to the 3 end of existing nucleotides, which forms phosphodiester bonds, which are found in between sugar and the phosphates that keeps the sugar and phosphate backbones together. Now, when this has occurred, DNA polymerase 1 comes and replaces these RNA primers with the now included DNA nucleotides.
After the leading strand has been formed, which moves towards the fork, the lagging strand continues to form, which moves away from the fork. So, DNA replication here started off with DNA primase, which moves along and adds not only one primase or one RNA primer, but 2 RNA primers. After the primers have been set down, DNA polymerase 3 moves along and adds the corresponding nucleotides. Okay. After the polymerase has added the nucleotides, DNA polymerase 1 moves along and gets rid of the primers and replaces them with DNA nucleotides. And right after, DNA ligase comes in and connects the Okazaki fragments together.